What's going on, Algebros? It's Mr. C here, and I'm going to show you how to sketch the following exponential function. F of x equals negative, and as our base we have 2/5 to the power of x. First thing you want to note here is that the base 2/5 is a value of a that's less than 1. So I'd like to go ahead and note that. Value of a is less than 1. 2/5 is equivalent to 0.4, so that's how we know it's less than 1. So since the base is less than 1, our base graph is going to start out in the following way. It's going to start out at positive infinity and then decrease its way through a y-intercept of 0, 1, hook off to the right to hover along the x-axis. And that would be our first graph, our base graph. There is a transformation involved in this function, and that transformation has to do with the negative here. Since this negative is in front of the exponential expression 2/5 to the x, there's going to be an x-axis reflection. So I'd like to go ahead and note that next. So if you remember my trick, since the negative is on the exterior of the base function here, there's an x-axis reflection. So the next thing I'm going to do is show you how to x-axis reflect our base graph. The key is to actually use the original y-intercept of 0, 1. When we reflect that across the x-axis, that's going to move to the location 0, -1. As for the rest of the graph, I suggest doing it in a couple of pieces. For instance, there's this piece that's in quadrant 1 that's hooking off to the right and hovering above the x-axis. We're going to mirror that across the x-axis, and what it's going to look like is it's coming close to the x-axis but now hovering underneath it. In a similar vein, we can take the piece that's originally in quadrant 2 and mirror that across the x-axis, and what that's going to look like is it's coming from negative infinity up through that new y-intercept of 0, -1. And that actually happens to be the graph that's our final graph. There are no more transformations to do. What we'll do next is include some additional details on this graph. The first one being the horizontal asymptote. Now originally the horizontal asymptote is always going to be along the x-axis, and since we're reflecting the graph across the x-axis and the horizontal asymptote is on the axis of reflection, it's not really going to change location. So for that reason, we're still going to draw a horizontal asymptote along the x-axis, and that would have equation y = 0. Another detail I'd like to include on this graph is the new location of 0, 1, which happens to now be at 0, -1 due to the x-axis reflection. A few more specs which I'll write off to the side of the graph. The domain. By default, the domain is all real numbers of an exponential function. The range for this function, due to the x-axis reflection, this graph is coming from negative infinity and hovering underneath the x-axis, meaning that the y values go from negative infinity and increase all the way up to 0, but not including 0. So for that reason, the range is going to be parentheses negative infinity, comma 0, parentheses. And we already noted on our graph the equation of the horizontal asymptote, which is y = 0. And the new location of 0, 1 is now at 0, -1. And that's how we do it. Feel free to let me know if you have any questions. Otherwise, thanks for watching.